This video is on a laboratory technique called titrations, and the calculations you generate from a titration are just a stoichiometry problem and are actually a stoichiometry problem dealing with just the reagents. A titration occurs between two aqueous solutions and is defined as using the molarity and volume of a titrant to determine either the molarity or the volume of what is called an analyte. So, what is a titrant? A titrant is the aqueous solution or reactant for which you know both the volume and the molarity, and that allows you to calculate moles. And the analyte is the reactant you are analyzing and will use the moles from the titrant in a stoichiometric fashion to figure out either the molarity or the volume that were used. As I said, they are just stoichiometry problems involving the reactants. So the if-then statements deal just with the reactants. It's usually used in acid-base and redox reactions and sometimes precipitation reactions. This can be set up as a limiting reagent question, but we will hold off on that till a further date. Now, in doing a titration, we talk about the equivalence point. The equivalence point is when you have no excess or limiting reagent, or you have a perfect stoichiometric ratio. When you're talking about acids and bases, you then say that the analyte has been neutralized. Now, the equivalence point is frequently signaled by a change in color of the analyte, and that color change is frequently due to the use of a chemical called an indicator, of which you only use 1 or 2 drops and it does not affect the overall reaction. This is a typical setup for a titration, especially an acid-base titration. The long tube is called a burette. The burette is labeled numerically from 0 to 50 to allow for measurement of milliliters, and it's usually done in tenths of a milliliter. You fill the burette to some point below the 0 line, and that's your initial volume. You then do the titration in a controlled fashion, and when you get the color change, you now have a final volume that you can read off the burette. And the final volume minus the initial volume is the volume used. Since moles divided by liters equals molarity, molarity times liters equals moles, you now know the moles of the titrant, and from that you can calculate the moles in the analyte. From that you can calculate the molarity of the analyte, or possibly the volume, depending upon the information you're given. So a typical titration problem would be running that experiment and then ending up with something like this. If it takes 25 milliliters of a quarter molar solution of sodium hydroxide to neutralize 15 milliliters of the hydrochloric acid, then what is the molarity of the hydrochloric acid? Now, to do this, you follow the stoichiometry rules. Start by writing out the correct balanced equation. Hydrochloric acid plus sodium hydroxide produces sodium chloride and water. I like to write out my information. I know that I have 15 milliliters or 0.0150 liters of hydrochloric acid and 25 milliliters or 0.0250 liters of sodium hydroxide. The molarity of my sodium hydroxide is 0.250. I don't know what it is for hydrochloric acid. That's the question I have to answer. When I do my calculations, I see that I have 6.25 times 10 to the minus 3 moles of sodium hydroxide, and I don't know the number of moles of hydrochloric acid. Now I set up my mole ratio, which happens to be 1 to 1. So when I do my cross multiplication and divide, I get that I have 6.25 times 10 to the minus 3 moles of hydrochloric acid, so I note it there. Question asks for molarity. Molarity equals moles divided by liters. When it's substituted in my values, 6.25 times 10 to the minus 3 moles divided by 0.0150 liters. And when I do that, I get 0.417 moles per liter, which is the same thing as 0.417 molar. That's all there is, a simple stoichiometry calculation. Okay, I've got 22.15 milliliters of an aqueous sample of silver nitrate. It takes 38.75 milliliters of a 0.332 molar solution of barium chloride to ensure that all the silver precipitates as silver chloride. The other product is barium nitrate. Okay, If I have 38.75 milliliters of a 0.332 molar solution of barium chloride, then how many grams of silver nitrate? I set up the balanced chemical equation. I write out what I know about the barium chloride. Do my calculations. I get 0.0129 moles of barium chloride. I write out what I know about the silver nitrate. I know the volume, but I don't know the molarity or the moles. I set up my mole ratio. When I solve for X, I have 0.0258 moles of silver nitrate. The question asks for the grams of silver nitrate, so I don't need to calculate the molarity. I need to use moles times molecular weight equals grams. I plug in my values, and this is my answer. So one last problem, this one you get to do. So read the problem, figure it out, come back, I'll give you the answer, we'll go over it, go. And the answer is 37.2 milliliters. Here is the correct balanced equation. I write out what I know about the phosphoric acid. I write out what I know about the calcium hydroxide. I've got 0.00674 moles of the phosphoric acid, and I don't know how many moles of calcium hydroxide. Set up my mole ratio, and then I solve for X. So I have 0.0101 moles of calcium hydroxide. Molarity is moles divided by liters. So I set that up. I can now rearrange it, solve for L, and now I multiply by 1,000 to go from liters to milliliters, and that's the answer. Now in actuality, since the question didn't ask for a specific unit, you could have left it in liters. So to review, titration occurs between aqueous solutions, and you use the molarity and the volume of the titrant to determine either the molarity or the volume of the analyte, with the titrant being the reactant for which you know both the volume and the molarity, and the analyte is the reactant you are going to be calculating either the molarity or the volume. They're just stoichiometry problems. You can figure out the if-then statement, and for titrations, it's the reactants. It's used in acid-base redox and precipitation reactions. It can be a limiting reagent question, but once again, we're going to defer on that. And we talk about the equivalence point. When you have no excess or limiting reagent, so it's a perfect stoichiometric ratio, and for an acid base, we call that neutralization. And that's titrations. In the next set of videos, we're going to tackle a new topic called kinetics.